Let's build a machine learning model to compete in a Kaggle competition. The goal of this competition is to predict student exam scores. I'm going to walk you step by step through how I built the model. Stay till the end to know how I placed on the leaderboard. We will be using a model called XGBoost. XGBoost is a tree-based model that builds a lot of decision trees sequentially. Each new tree focuses on fixing the mistakes made by the previous ones. This makes it a very powerful model for structured tabular data, which is why XGBoost is one of the most popular models in Kaggle competitions. Step 1 is importing our library. We'll be importing pandas for data handling, scikit-learn for evaluation and predictions, and XGBoost for the model itself. Step 2 is loading our training and test dataset that we got from the Kaggle competition. The training set includes both the student features as well as the exam scores, while the test set is missing the exam scores. Before doing anything else, I like to look at the head of the dataset. This helps me familiarize myself with the data and understand which features we're working with. After this, I check summary statistics, data types, as well as missing values. In this case, the dataset is very clean, which is amazing. Next, we separate our target variable, which is the exam score, since it's what we're trying to predict. Everything else will become our input features for our model. We will also be removing the ID column since it doesn't have any predictive value. Now, this is very important. Whatever we do to the training set, we also want to do to the test set. Now we get to one of the most important steps, encoding categorical features. How do we know which features are categorical and which are numerical? I personally check the data types and look for the object data type. Once we find out which features are categorical, we don't just encode all of them in the same way. Some categorical variables have a natural order. For example, exam difficulty, easy, moderate, hard, or sleep quality, poor, average, good. For all of these, we use ordinal encoding where we map categories to numbers while preserving the ranking. Other categorical features don't have a ranking at all, such as gender or study type. For these, we use one-hot encoding, which creates binary columns for each of the categories, so the model doesn't assume any ranking which doesn't actually exist. Again, this is super crucial. Whatever we're doing to the training set, we're also doing to the test set. If not, the model will break. We're almost there. Now we're defining the XGBoost model. We have created a very simple model with no hyperparameter tuning or feature engineering. The one important thing I do include is early stopping, which tells the model to stop once performance is actually decreasing. Instead of creating just one training and validation split, I use k-fold cross-validation. This means we train the model multiple times on different subsets of the data, and we evaluate the model on different validation sets. This gives us a much more reliable idea of how our model will perform on unseen data. The competition is evaluated on RMSE, or root mean squared error. A lower RMSE means a better prediction, so that is what we track along all of our folds. Once we're happy with the setup, we train our model once again with all of the training data. This gives the model as much information as possible before making the final predictions. Finally, we generate predictions on the test set, we clip them into a realistic range of 0 to 100, and we create the Kaggle submission. With this very simple model, no feature engineering or hyperparameter tuning, we managed to get an RMSE of 8.7.